Hello everyone. We're going to have a quiz 1 revisit. This is the statistics of our quiz 1. Basically, most of you performed quite well, so we have 52 students who got full score of it, and the average is actually 93.5. And for those who did very well, it's usually due to the following mistakes. The first one is probably the answer did not meet the question. And the second, the answer might not fully answer the question. And the three thing is a reminder that you can actually use both English and Chinese in your answers, even though the question is in English. And for those of you who wish to improve your grades, I would suggest the following. First, you can read the question several times. Make sure you understand what the question wants before you attempt to write down your answer. And second, for each request in the problem description, for example, in the third question of this quiz, there are 3 specific items. So you should provide the answers one by one. Sometimes the items in each question is not explicit. So in that case, you should read the problem carefully and answer each request separately. And since you might already notice that in this quiz, the questions are from our homework, and the solutions were actually provided in our course website. So you can study the solution provided for the homework. And if you still don't understand the solution, think the solution sometimes might be too simple, you can discuss with your group mates. Okay, so let's take a look at the first question. This question gives us two vectors, a1 and a2. And a b vector contains an unknown notation, h, right here. The question asks us for what value of h is b vector in the plane spanned by a1 and a2. So according to the definition of span, we can decide whether b vector is in the space spanned by a1 and a2 by checking the matrix A formed by first column a1, which is 1, 3, minus 1, and the second column minus 5, minus a, and 2. Then b vector is in the plane spanned by a1 and a2 if and only if ax equals to b is a consistent system. In order to check whether this system is consistent or inconsistent, we should use Gaussian elimination. But there is a notation h, which is an unknown value involved in vector b. It's okay that we put such a notation h in the process of Gaussian elimination. So basically, we just put h there in our augmented matrix and use the same process of Gaussian elimination and see what will be the relationship we get at the end with this h involved. So you can see I put down the a1 and a2 right here, and then also b vector right here. Oh, sorry. B vector right here, and h is involved. And then I still do the row operations to eliminate the numbers 3 and minus 1 to make them reduce to zeros. And as a result, I can continue to use 7 as a pivot to reduce the number minus 3 into 0. And at the end, I can obtain such an echelon form. This is an echelon form because the lower triangular part, these 3 values are zeros, and it satisfies all the requirements of the echelon form. So I can start to evaluate the value of h. In order to make this system a consistent system, the bottom line, the third line, has to be a solvable equation. So I should read 0 times x1 plus 0 times x2 equals minus 3 plus h. And the only possibility is that minus 3 plus h equals to 0. So h can only be 3 in this problem. And question 2. We're going to show that a t function is a linear transformation. And t function with input x1, x2, x3 is written as the output being a two-dimensional vector. The first dimension is x1 minus 5x2 plus 4x3. And the second dimension is x2 minus 6 times x3. So this question is to test you about the fact that every linear transformation can be written as a standard matrix form, A times X. So for this T, which is a function, so far it's written as a function format. If we can transform this format into a matrix form, which is a matrix A times a vector, that is A times X, then we can verify that this function is actually a linear transformation. So we can go ahead to write down the matrix A. So we can just do the observation. And we find out that if we write x1, x2, x3 as a vector right here, and by observation, we find out that the first equation is actually 1 times x1 and minus 5 times x2 plus 4 times x3. So I put 1 minus 5 and 4 right here as the first half of the matrix A. And for the second half of the matrix A, I observed that the second entry, the second dimension of this t function is 0 times x1, I put 0 here, plus 1 times x2, so I put 1 here, minus 6 times x3, so I put minus 6 here. So I have created such a matrix A times vector x, and x has 3 elements, x1, x2, and x3. And this expression is a matrix expression. And the result of this matrix expression is actually the same, identical or equivalent with this t of x function. So this process has shown that this function can be written as a matrix form. And because of this result, we can say that t is a linear transformation. The keyword is the phrase linear right here. Okay, for question 3. Basically, this is a mining company, has 2 mines. Basically, you need some readings for these questions. And here are some Chinese translation. Basically, we have ores contains copper and silver. And we notice that the units of copper and silver are not the same. For copper, it uses metric tons. For silver, it uses kilograms. But obviously, this question did not want us to convert the units to be for Cooper and Silver to be identical, because we see that V1 is directly introduced as 30 and 600, and this is 30 and 600. But the units of 30 and 600 is not the same. 30 matrix tons and 600 kilograms, but it doesn't matter. And so we do not need to worry about what is this unit actually mean, and then try to convert them into some uniform unit. No, we don't need to do that. Instead, we can use these two vectors, V1, which is 30 and 600 directly, and V2, 40 and 380 directly. So for those who understand Chinese, you can read the translation here if you have some doubt about the problem descriptions right here. Okay, the question A. What physical interpretation can be given to the vector 5 times V1? So since V1 represents the 1 day operations at mine number 1, the production of 1 day's operation at mine number 1. So 5 times V1 means 5 days operations at mine number 1. And question B. Suppose the company operates mine number 1 for x1 days and mine number 2 for x2 days. We can write this statement as a mathematical expression. And the mathematical expression is x1 times v1 plus x2 times v2. This represents x1 days operations at mine number 1. The second half represents x2 days operations at mine number 2. And the second half of the question asks us to not just write down this mathematical expression, but also try to equate the output to 240 units of Cooper and 2,824 units of silver. So this expression should be equivalent to a two-element vector with 240 put here and 2,824 put here. And this question wants us leave this expression here without solving the equation. So we just need to write down this expression for question B. Question C. Solve the equation in B. So since V1 and V2 are given vectors in the previous page, then we can solve it as a linear system by putting V1, which is 30, 600, and V2, which is 40, 380. And we form a augmented matrix. We call that augmented matrix is to put the coefficients in the left-hand side, which is V1 and V2, and then put the right-hand side also in the matrix. So the first two columns are from the left-hand side, but the third column is from the right-hand side. We put the coefficients all together in a matrix. And this augmented matrix is where the Gaussian elimination should be performed. So we are going to use the Gaussian elimination to reduce this matrix to solve the value of x1 and x2. And this is the detailed process of Gaussian elimination. This is the augmented matrix. And then we want to reduce the value 600 into 0 as the second matrix show. So I choose 30 as my pivot and multiply minus 20 of the first row and add it to the second row. As a result, the second row is reduced as 0 and minus 420 and minus 1976, where the well, the first row remains the same. And this is already an echelon form because this is a 2 by 2 matrix of the left-hand side, regardless the right-hand side. This is a 2 by 2 matrix. And the bottom left element is 0. So it becomes a echelon form. So we are ready to write down the equations corresponding to this echelon form. So this maps to these two equations. So I have 30 times x1 plus 40 times x2 equals 240, and minus 420 times x2 equals to minus 1976. And these two homogeneous equations are from the echelon form matrix. Okay, and then next we can continue to compute x2 as this value, 494 over 105. And x1 equals to 544 over 315. So this is our answer. And this process can be obtained in this website. You can go to this website and find out the solving equations page, and then enter the augmented matrix or enter the coefficient of the equations, and then this process will be generated. So you can use this website to check your solutions of your homework or exercises. Question 4. So we are given a matrix A, and it's stated in the question that we already know that first column minus 3 times the second column will be equal to the third column. And this fact implies a property called linear dependence of the matrix columns. So if the columns of a matrix are not independent, which is linear dependent, then there exists non-trivial solution. Non-trivial solution means x not equal to 0 of ax equals to 0. And such a system where right-hand side b is replaced by 0 vector is called a homogeneous system. So this is the fact of this observation. The observation is the first column minus 3 times the second column equals to the third column. This is the observation. And immediately it leads to the properties of linear dependence. Here I put the bolded form for linear dependence because that's the key of this system. And also we will know that the non-trivial solution exists for homogeneous systems. So those are the properties we should also know when we read this question. But then the question wants us to find such a non-trivial solution. So it means that even though you do not exactly remember the terminology right here, you can still find a non-trivial solution of ax equal to ax equal to 0, because to find non-trivial solution of even though it's a homogeneous system or linear system, the process is Gaussian elimination. We all use the same process, which is Gaussian elimination, to solve such a problem. So we're going to perform the Gaussian elimination for this matrix A in the next page. So I put the matrix A on the left-hand side, and now my right-hand side is 0, 0, 0. This is a homogeneous system. So now it becomes a 3 by 4 matrix. I need to work on such a augmented matrix instead of just the matrix A. All right, so I choose my first pivot as 4 and do the row reduction. I want to reduce minus 2 into 0. So I multiply 1/2, 1/2 of the, I multiply the first row by 1/2 and then add it to the second row. And also and it gives us my second matrix. And I also multiplied the first row by 1/2 and then add it to the third row. Then it will reduce this -2 again. And then I get my third matrix. I notice that I can continue to choose another pivot, which is -1/2. This one is my second pivot. So I multiply the second row by -3 and then add it to the oh, I should, yeah, and then add it to the third row, and then that reduce this element to 0. So this fourth matrix right now is an echelon form. I can check this is an echelon form because yeah, you have a bottom left elements now become zeros. So this is an echelon form. So I can convert this echelon form into the homogeneous equations by putting x1, x2, and x3 next to the coefficients provided in the echelon form. So this will be the final homogeneous equations, meaning 联立方程式. Then I can continue to solve, and I found out that I can actually write it as a, let me reduce it. I can write it as a x2 equals to 3 times x3, and then x1 equals to minus x3, and provide my answer as this one, which is x3 equals to x3, and x2 is 3 times x3, x1 is minus 1 times x3, or I put a general solution in a vector format, and x3 can be any value. So if I put x3 as 1, then this x is -1, 3, and 1. And that is a non-trivial solution since this is not a all-zero vector. So this becomes a non-trivial solution to answer this specific question. So this is all for the quiz 1. And I hope you continue to improve your skills and then with some good grades in the next quiz. Okay, see you and bye bye.